Welcome to Radar System course. Today we continue the tracking in a range here. So in this particular topic, we see that how this target is continuously tracked in a radar, tracked by radar in a range, as well as in a angle here. So we need to consider that a range and a angle. So what will be the angle? Angle in this case we consider that the azimuth as well as the elevation. So while tracking a target, so what will be the range of the target? What will be the angle in terms of azimuth and elevation? Generally, if you consider the object, so right now if you see that this one is nothing but a ground surface, on a ground surface we have the antenna is placed, and this one is nothing but your object. So when we look toward the object, okay, so this one, from this radar we send a signal, so we can find out what will be the range. Okay, that is about the length, what will be the range of the radar from this antenna or from this radar to the objective or a target, as well as the target position of a target with respect to that. If you consider that horizontal plane, we need to know about that what will be the elevation here. And from this we can find out, from the given particular reference point, what will be the angle here. Okay, so this one, so we can consider that both the angle from this horizontal, that is about the elevation, and from this vertical side we need to know about what will be the angle, that will be called as a azimuth angle. So we need to find out here a azimuth angle as well as the elevation angle. Now that range we consider, okay, by the radar. So in that case, what are the various operations to be present in the given radar? So there are the two types of radar, in which one is operated by manually and one is operated by the automatically. So when signal is to be sent by the radar, so on the display devices we are able to see some target or some particular object is present. Suppose I say that this one is about a display device. So we supposed to learn that these are some particular components. So we just vary this, because radar continuously sending the signal, continuously scanning the object is present or within a particular range or not, and then we supposed to find out somewhere the object here. Okay, so this one is nothing but the display. Okay, so now this signal, if you see that this one is varying continuously, that is about a scanning. Scanning can be performed in terms of a conical scan or a helical scan. So we'll see that as per the display devices, what type of scanning is required. Okay, so we'll see in detail. So now, if you consider what type of a display we have, okay, that according that we use different types of a condition before applying the signal to the display here. So we have seen earlier that a video amplifier, and it will be display the signal, and that signal has a particular label present, then and then it is to be displayed now. Now when we send a signal, okay, if the target is within the range of the radar, then automatically we can obtain that what will be the range here. Then similarly we need to find out the angle. Okay, angle, that is about a range as well as the angle. But sometimes what happens, if the target is beyond this range of the radar, so in that case the target could not be identified by the radar here. So in that case we need to continuously, okay, that radar continuously send the signal in a space. When that target will reach in a given particular range of the radar, then the target position is to be identified by the radar, and then continuously track the particular target. Okay, that is about a continuous tracking radar. In this case, it will continuously tracking the object within a particular period of time. Okay. Now, in this case, two methods are there, two operations of a radar. there are two types of a radar: manual operation radar, or you can say that auto tracking. So in a manual, identifying the target and then identify which direction that target is moving, and according to that rotate the antenna toward the given particular target, okay, within that particular direction. That is about a manual tracking. Or we see that our object is present, and then we can find out what will be the range, what will be the distance of the target, just like missile tracking or aeroplane tracking. Old days that plane was very slow speed. Right nowadays it is very that whatever the fighter planes are there, it very fast now. Even that faster target can be observed, faster plane can be observed by the radar. So in that case, instead of a manual tracking, a auto tracking method is used. So in this case, once the target is identified by the radar, it will log the position with the given particular target and then continuously scanning or continuously tracking that particular radar. Initially continuously scanning the region, once the target is observed by the radar, then continuously track the particular target in a given particular direction. Okay, up to what? How long that target is available in the given particular range. Now, mostly this one is used to identify the target for that in a missile tracking, or we can use this technique in a war zone place where we need to target where we need to track the missiles, or we need to track the a fighter planes like that. So sometimes what happens, the speed of the target is very fast now. If it is very increases there, okay, so in that case that that radar tracking the given particular target, it is very difficult. If you consider in a manual case, it is very difficult. If you consider that even if it is in automatic one, but for the automatic we need to know about that how fast that radar, that particular antenna system is going to be rotating based on the echo signal we have received. So through that way, so that range, or through that way, that target can be captured or target can be tracked with the given particular range as well as the angle. Then what are the various technique for the automatical tracking? Because in a tracking we need to find out what will be the range here. Okay. So in that case, we are supposed to consider that whatever the echo signal we are receiving, okay, based on that, or whichever the echo pulse we are receiving, based on that echo pulse signal, we need to find out whether the target is moving in this direction or whether that target is moving in that direction, okay, in which direction. And according to that, we need to track the given particular target. So for that purpose, there is a technique for automatically tracking radar, and that technique is called as a split range gate tracking. So in the split gate range tracking system, so what happened? So if you consider that, generally whichever the echo pulse we are receiving, this one is nothing but we are supposed to consider that echo pulse we are receiving. Okay, it's not mostly, it's not a square shape. Okay, just like a small slight variation is there. Okay, this is about the echo pulse we consider. Now for the given particular echo pulse, this is nothing but a time now. So for a given particular echo pulse, we need to know about that splitting this particular range gate here. We are receiving the echo pulse. We need to find out what will be the range gate for this particular echo pulse. So in this case, we will find out a early gate, or we will get that early gate and a late gate here. Suppose I say that this one is about a early gate and this one is about a late gate here. Okay, so I supposed to consider now. So this one is about a early gate and this one is about a late gate. Okay, we can see that early the late gate now. Okay. Now, then the portion of that particular, whatever this one is a echo now, echo pulse, and this particular portion of echo pulse and this particular whatever the early late range gate is there, that will be differentiated. So means, so whichever the portion, if you consider that those have the energy larger or those have the energy lesser, according to that we need to find out the error signal. So different signal between the early gate and in late range gate, if you compare with the echo pulse, so we are getting that this one is about, we can say that the early gate here. Okay, so we can compare here because this one is about a center, and from this I supposed to find out, okay, this one is about the, we supposed to consider that this one is about the early gate here. This is about the early gate pulse. Now, if you compare that a late gate here, this one is nothing but the a late gate now. Okay, what we can say that, okay, this one is about a late gate and this one is about a early gate, and this we are getting differentiating this particular signal between the early and a late gate. Okay, so if we compare with the echo signal, whatever the echo pulse we have, and then we need to subtract that output of these two gates, and that will be subtracting the output of these two particular gates, we will get the error signal there. And based on that, whatever the error signal we have received, and that will provide you the what, where the direction of the target is there. Okay, if we consider that the difference between the whatever the center pulse and the center of the gate here, and that is about the error signal we are getting. Okay, so from this, what will be the position of the target, so that can be identified. Means we can say that whatever the error signal we are getting, that error signal is used to determine the direction in which that particular gate is present. Okay, so we can find out that this echo pulse and early gate and late gate, so that if this one is match here, if the difference is 0 here, in that case that will be useful for the tracking there. Okay, so means we can say that we are able to identify, or that target is locked with the particular system, and then we are able to identify what will be the target position now. Okay, so we can find out the range as well as the what will be the angle here. So simply the signal, whichever the echo pulse we are receiving, okay, that echo pulse at a receiver, we have at a receiver we need to find out what will be the level of this particular received signal, and then echo signal consists of, we can say that a clutter, but we mostly consider the whichever the signal received from the target, and that signal is used to find out the what will be the a range here. Okay, and then this one is about a range related, but what about the angle? So in the case of a angle here, we need to find out, or we need to locate the target first, and from the location of a target we need to find out the what will be the angle here. Sometimes that we can say that a target is moving, so in that case there may be a small variation in the angle. In that case, while tracking the target, so due to the, while tracking the target, there may be introduction of a noise here while introducing the noise by the target or by the signal. So range may get vary because of the noise, as well as whatever the angle we are measuring, that may fluctuate here. So then in that case, it is difficult to find out the range as well as the this particular angle there. So that's why we need to use automatic tracking instead of a manual tracking, so that a target can be tracked using the whatever the signal to noise we are measuring, okay, we are getting, and based on that particular signal to noise we need to eliminate the noise, and we need to find out, or we need to get exactly particular signal, and then we can find out the what will be the range as well as the angle there. Okay, that is about a tracking range. Now next about topic, okay, we can consider that a acquisition. So acquisition means what? We need to consider that find where the target present. Okay, so this one we can consider that a acquisition now. Okay, in the case of acquisition, what happened here? A tracking radar need to find a target first. Okay, acquire its target, and once it acquires its target, then your radar will be act as a tracker now. Okay, first of all, if the target is present within a given particular range, okay, so then find out the target present in the particular range. Once the target is obtained, and then track the given particular radar. Then while tracking, okay, we need to consider various kinds of a antenna there. So mostly if you consider that a pencil beam antenna, okay, the pencil beam radar antenna. So this one is about a pencil beam. So in the pencil beam antenna, okay, that is very useful to track the a target there. So in that case, that whatever the beam we are getting from this antenna, it is very narrow. Okay, we can, that's why we say that a narrow beam antenna or a narrow pencil beam antenna is to be used for the tracking purpose there. So this narrow beam means it is continuously scanning the given particular space, means signal is to be seen by the radar, it is continuously rotating, that antenna is rotating continuously, and that rotation of the antenna, it is depending upon that what type of a antenna we are using. So generally 30 rpm, okay, likewise. So this one is depending upon that what will be the revolution per minute by this particular antenna, means antenna is rotating for the tracking purpose. So in this case we need to send the signal. Sometimes that radar doesn't know that whether the target is present within a particular range, but that radar is continuously sending the signal in a space, means it has the antenna, it is continuously rotating, okay, while rotating it is sending the pulse signal, and it is receiving the pulse signal. At one particular moment, if the target is present within a range of the radar, then target will be acquired, and then it will be a track here. Okay, so mostly what happens, we need to just find out the object in a dark, okay, while scanning. Okay, we need to scan. So within the particular range, if it is present, then it will be tracked. So then what particular methods are used to scan this particular target? Okay, so mostly if you see that whichever the beam antenna we are using, so it is rotating now. Okay, so antenna is rotating. When we say that a antenna is rotating, so in that case we need to consider that what will be the type of scanning we are using. Okay, so we should know that what will be the scan. So scan means what? Whether we can consider that is conical scanning antenna, okay, or whether we consider that a shape of antenna that will be a parabolic one. Okay, so what type of a antenna we supposed to use for the scanning purpose? Okay, so phase array antenna. Likewise, various antennas are there. So that antenna is continuously rotating. Okay, that antenna is continuously rotating. So if you consider that a parabolic antenna, it will be continuously rotating in this direction as well as in this direction, in both directions. So means we will get the angle azimuth as well as the elevation there. Okay, azimuth as well as the elevation. But once the target is locked by the antenna, so will get the range. Okay, but what about the azimuth and elevation? So in that case, while rotating the antenna, okay, continuously scanning the target, and it will obtain the azimuth as well as the elevation there. So if consider that if there will be the a pencil beam antenna, so that pencil beam antenna, that antenna is that has a narrow beam. So this one is about the position of the antenna. So it will be continuously scanning, means it will be rotating continuously, okay, within a particular range. Okay, so likewise, and then through this particular range, so we will get the angle in terms of what, a elevation now. So what about the azimuth now? So in that case, for the azimuth, we need to rotate the antenna. Okay, instead of this one, we need to rotate the antenna from way this way here, so that we'll get the azimuth there. Okay, so we can find out the if azimuth as well as the elevation angle. So mostly that antenna, we say that it is rotating, continuously scanning. Means if I consider that from the given particular point, so point of a target, so it is rotating in a spiral manner also. Okay, so continuously scanning. So we are getting the object within the particular range. Okay, it is about a continuously scanning. So sometimes what happens, a radar is rotating. So we will get the pattern. It's just like a helical one. Okay, so it's called as a helical scanning here. So in that case, we supposed to find out that a given object. Okay, so likewise, this one is about the helical scanning here. So it will rotate it now. Okay, or we can find out that another way here. We need to find out the elevation while changing the little bit azimuth here. Okay, this way we can scan here. Okay, this particular scanning is called as what? We can say that a Palmer scan. Okay, and this one is called as a helical scan. Okay, this one is called as a helical scan. Or we can use another, that this one we can say that a scanning in a TV here, like that is about a raster scan. Okay, this way we send the signal. This one is called as a raster scan. Or we can consider that in this type of scanning, just like oscillation scanning here. Okay, it's just like a oscillating one. Okay, that is about a type of a scanning. So we have seen this a four type of scanning here. This one is about a helical one. Okay, this one is about helical one. This one is about what we can say that a Palmer scan. Okay, this one is about a Palmer scan, and then we can consider that a spiral scan. Okay, now these are the spiral scan. So these are about the various scanning technique that will be useful to find out the a angle here. So if you consider that a helical scan now, for example, a helical scan. So in which in this particular case, what happens? Antenna is continuously rotating. Okay, it is continuously rotating in terms of what? In a azimuth here. Okay, in a space here. Okay, so that's why it is in a azimuth. And then what we can say that it is continuously rotating, okay, in the azimuth. So it changes a smaller elevation. Okay, so with a elevation changes. Okay, so likewise, so scanning the antenna, okay, that antenna is rotating with the given particular elevation there. So for example, if you consider that a antenna is rotating with what, a 6 rpm. Okay, for example, so for a given particular 6 rpm, it is to be used, or it is to be covered a 20 degree of a elevation angle. Okay, 20 degree of elevation angle in 1 minute for the helical scan there. and this was used in a World War II. This type of a scanning, illegal scanning, was used in World War II. And in the case of a Palmer scanning, so what happened here? So in this case, what happened? So it just continuously scanning. Okay, this is just like a, we have a circular scan, or we can say that is conical scan. Okay, conical scan like so means antenna we supposed to consider that it is rotating, but while rotating it is moving in the given direction. Okay, so if you consider that it is rotating, but it is again moving in the given particular. So this one is about the case of a Palmer scan here. So it has some circular movement as well as some linear movement here. Okay, so means your axis, if you consider that this axis is the stationary now. Okay, in a Palmer scan the axis is stationary, but it has some linear movement, and this will be produced by the a conical scan. Okay, so in most of the cases this helical scan as well as this Palmer scan are used. Okay, because they are continuously tracking the target, and they are moving in a linearly one. Okay, so if you consider that word, we say that a conical scanning, sequential low beam, or you can say that monopulse tracking. So uh, in this case, mostly this Palmer scan is used here. Okay, because it is this this antenna is continuously scanning in a conical format here. You can say that a conical scanning or conical tracking radar, as well as it will be moving in the a linear motion. Means we will get that what variation in the azimuth as well as the variation in the elevation there. Okay, so that's why we can consider that a Palmer scanning. Another scanning is what? In this case, it is a fixture. So instead of that changing the area, okay, that's about a spiral scan. Means in this case, whatever the angular search volume we consider, that will be in a circular symmetry. Okay, if you consider that in a spiral scanning, it is about a conical scan. But again, it is the same. But only the difference is what? So that the volume will be larger. Okay, so initially it is a small volume, it will be a large one. That's called as a conical scan. Raster scan. This one is about raster scan. Just like we need to consider. Okay, horizontal then vertical. Okay, likewise. Okay, just like searching the antenna within a particular tracking the radar within tracking the object within the particular case. So that is about a raster scanning there. Okay, and this one means if you consider this one, it is a slowly varying the what we can say that azimuth as well as the elevation there. Okay, in the raster scan. Again, if you consider that this one we have, okay, so we are supposed to consider that it is about a continuously scanning. Okay, so it is about a sinusoidal one. So continuously varying the elevation as well as the azimuth. Okay, these are about the a acquisition as well as the scanning of a radar here, target by the radar. Now then we will compare that what are the various tracking radars we supposed to be used there. So mostly if you comparing the trackers, okay, if you compare comparison of a tracker here. So we have considered that various types of a tracking radar, so in which it is used a sequential lobing, okay, and mostly that a tracking radar they are using a tracking technique that is called a sequential lobing. Then we can consider that a conical scan, okay, then amplitude comparison, Okay, so we can consider that amplitude comparison, monopulse. Okay, that is about amplitude comparison, monopulse tracking, and phase comparison, monopulse tracking. Now, in the case of a sequential tracking that we have learned earlier, okay, so sequential tracking. So it is a time sharing basis. Okay, single pulse is used, single pulse is sending based on the time sharing. Means two beams are used. So in that case, we can find out what is the squint angle, as well as we can compare the we can find out the amplitude. Okay, likewise. In the case of a conical scanning, we have seen that, okay, scanning with the same pulse, okay, but slightly varying the a position now. Okay, so that is about antenna we are using, what type of antenna in terms of a, if you consider that a conical scan, okay, and mostly if you consider that a conical scan and scan, amplitude comparison, monopole scanning, okay, that is about a tracking radar. Both are similarly used, or both are similar, and both are just comparing the somewhere it is comparing the amplitude, and they are mostly used here. If you consider that a phase comparison one, okay, so phase comparison monopole, it is not used most of the, it is not popular one, because it's just changing the phase, and for phase comparison we need to use a four antenna, okay, and that four antenna is to be energized by the single pulse. So if you consider that four antennas, so we will get a various side lobes, and because of that, it is very difficult to find out the variation in the phase here. So that's about, we can say that a phase comparison antenna, because four antenna is to be sending the signal in a particular direction. Okay, so that's about the difficulty for the a phase comparison antenna. So that's why this phase comparison monopulse antenna is not used. If you consider that in a monopulse tracking radar, so instead of a phase comparison, amplitude comparison monopulse tracking radar is used. Okay, so in that case, we will get the radiation pattern, so we can find out what will be the amplitude comparison of the a pulse like that. Okay, so we can find out, or we can say that a angle tracking also. Okay, so likewise, so we can find out a, if you compare this, so we consider that a conical scan and a amplitude comparison both are better here. But if you compare again, if you consider that a conical scan as compared to this one, so conical scan has a less loss, and the antenna feed system that are used for the conical scanning, it has a very less complex one. Okay, less complex system is used, so we can say that it has a very less loss there. And in the case of a conical scan, so mostly we can consider that a scanning system what we are using in comparison with a monopulse and a conical scan. So in a monopulse, it is used as simultaneous scanning, but in the case of a conical scan, it is using a sequential scan. Okay, sequential lobing and a sequential scanning is different. Okay, so and if you compare that a signal to noise ratio in a monopulse tracking, it is better as compared to the a conical scan radar. And then accuracy in terms of angle is better in a monopulse radar. Okay, it's not better in a particular a conical scan radar. But if you compare that accuracy, but if there is a variation in the angle, okay, small variation in the angle accuracy, so angle accuracy will not be affected by the whatever the echo signals we are receiving through the fluctuations in terms of monopulse radar. Similarly, even if there is a small variation in the angle accuracy, so it will not affect a conical scanning system. If you compare that, which one is used mostly? Because earlier case that conical scan was used, and later people are using a monopulse tracking. And if you compare this amplitude comparison, we are supposed to use a two feeds, but in the case of a conical scanning, a single feed system is used. So in terms of feeding system, so it is about a less complex, but if you compare with a monopulse tracking amplitude comparison, so it is about a very much complex here. And then for the rotation, if you use monopulse tracking, so rotation of the antenna beam speed, okay, that rotation speed is very low as compared to the conical scan. And monopulse tracking requires a single pulse, because we use a single pulse and two antenna single pulse is to be sent. But in the case of a conical scanning, we are supposed to send a minimum of a 4 pulse to scan the given particular radar. That means with a sequence, okay, so we can say a pulses and we can find out the what will be the a coordinate there. So we'll measure the angle as well as the range through this particular tracking system there. But if you compare with respect to the cost, because it requires a complex system of feed system, it requires a more than two antennas. So as compared to the conical scan, so monopulse tracking is very costly, and a conical scan, it is about a very less low cost, okay, low cost system. So we can mostly prefer for the tracking a conical scan as only, or conical scan or a monopulse tracking, because this system are better as compared to the sequential lobing as well as the phase comparison there. And if you compare that a signal to noise ratio, okay, there is a small variation in the particular signal to noise ratio, because if you compare this one, okay, so it has a higher signal to noise ratio, but it is about a small variation in the signal to noise ratio in the conical scanning there, because we say that a signal to noise ratio available from the monopulse tracking radar is greater as compared to the conical scan radar there. And for the particular signal to noise ratio, okay, when we compare the signal to noise ratio, so that in that case we need to consider that the antenna we are using in a conical scan as well as in a monopulse tracking, you should have the same size aperture as well as the beam width of whatever the radar there, so that we can compare that a signal to noise ratio as well as the focus. But if you consider that a focus, in the case of a monopulse tracking, it is using a offset focus, okay, not it is of on axis there. But in the case of a conical scan, on axis system is there. So that's why the tracking accuracy, if you compare the monopulse radar, it is superior as compared to the conical scan radar there. Okay, so that's all about what we can say, that a comparison of a target trackers, and we have seen that a tracking radar, and that tracking radar is useful to determine the location of the target. Single target trackers track the missiles, automatic detection, and a tracker is used in a surveillance as well as the air traffic control radar. Track while scan, that was used in air defense, aircraft landing, and for tracking multiple targets there. monopulse tracking radar, we will get the angle error information, and that will be used to obtain on a single pulse there. A phase comparison monopulse that are called as a interferometer radar, and in a sequential lobing, if you consider the beam is switched between a two angular position on a time sharing basis, and the tracking radar tracks the target in terms of a azimuth and elevation, so we can find out what will be the range as well as the angle in terms of a azimuth and elevation there. So there are the various types of antenna and various types of modes in a tracking radar. So some radar they provide the range along with the azimuth and elevation. Some radar are called as a three-dimensional search radar. It provides a three-dimensional data that is called as the azimuth, elevation and a range data. Some radars are called as a 2D search radar, so in which they are providing the information in terms of azimuth and a range, and mostly the tracking radars are used for the range tracking, velocity tracking and a angle tracking. That's all about a tracking radar. So with this we stop here. So thank you all.